Welcome to Impulse. For about a year now, more than 8 billion people have been living in the world. 8 billion people who need to eat and drink in order to live. A challenge that is not getting any easier due to the consequences of global warming. But how can we still succeed in feeding the world's population? We present two exciting approaches and talk about their potential. Also, we look at the role of automation in this. First, however, we will talk in general about the importance of a digitized food production chain. And that's what I'm now talking about with my first guest, Johan van Niekerk. Johan, thanks for joining us today.
Thank you.
So maybe let's start with the big picture of digitalization in the food industry. What role does digitalization and automation solutions already play today in this industry?
Yeah, so digitalization plays a crucial role in the food industry by enabling greater efficiency, transparency, and sustainability for the complete value chain from farm to table. I think one of the challenges for most people is, what does digitalization mean? It means different things for different people. So I think here in IFM, we are focusing on adding value to our customers by optimizing processes. We are focusing on reducing waste and increasing output. Now, on the topic of reducing waste, it's also fitting this year that the Food and Agriculture Organization has chosen the topic water savings for World Food Day. Now, IFM is able to offer various types of solutions when it comes to energy data monitoring, in which water is a very, very important part. And we are able to offer very simple solutions by comparing input and output, but we're also able to look at more advanced solutions where we are able to look at different batch monitoring and compare it to the different producers being produced.
All right. So as we are today have a stronger focus on the agriculture sector with aquaculture and vertical indoor farming. What advantages can bring automation solutions in this specific sector?
Yeah, so for me, it's very interesting now is we've seen that there's a lot of development happening in agriculture. People are questioning the status quo. They are not producing as normal. They have to find ways to be more effective, more efficient, to increase the output. People are re-engineering their current processes, which then means that there's a lot of opportunity for automation and digitalization in agri-farming or agriculture. I think also it's very well documented that 70% of water is currently being used while doing agriculture. And it means we need to be smarter in ways of how we can produce food security going forward. So IFM is able to reduce water by 15% when we talk about irrigation machines in outdoor farming. But also IFM is able to participate in topics like vertical farming, which we are able to save up to 95% of water usage compared to agriculture. And then, of course, when we talk about aqua farming, fish farming, there is a system called a RAS system, a recirculation system for water, which we can save up to 99% of water usage. So all these are digitalization topics which can be improved and helping the agriculture moving into a new direction.
So when we get more into details, what really specific solutions does IFM offer for these challenges the industry is facing?
A lot of customers around the world know IFM for certain topics. They know IFM as a position sensor company. They know IFM as a flow company. But what IFM has to offer, and this is not what everybody is aware of, is we can offer solutions for the complete value chain within the farm to table solutions. So currently we're able to offer solutions in outdoor farming, indoor farming, livestock, alternative proteins, the complete processing part, as well as cold chain and logistics. So going down to the more technical details is that IFM is also able to capture all the data on the plant side, but we also have the capability of taking this information to a higher level of communication, which then enables digitalization, smarter decisions, and of course, increasing the output.
So if I was a customer of IFM, or if I was into the industry sector, and I would say, okay, digitalization is a topic for me. I'd like to start. I'd like to get my processes more efficient. How would you suggest to start and how to take the next steps?
Although we've seen a big increase in agriculture automation over the last few years, the reality is that not everybody is in the same position to start automating. So I think there's a few basic questions that somebody needs to ask themselves when they think about digitalization and automation. The one obvious question is at what stage does my labor output becomes more or less effective than automation? We need to look at efficiency, increasing efficiency, production, but also another topic which is very big when we talk about reducing waste is quality and reducing waste. So when this equilibrium is faced and the customer or the producer can actually have more output and yield, then the next logical step will be to start automate or digitalization. It's also clear that a lot of the farm equipment already is digitalized. So we don't say that start from A to Z and digitalize everything.
Yeah.
There are certain typical or very important processes inside the agriculture which can be automated. So my suggestion would be to look at your complete setup, evaluate based on the questions and see what is needed going forward. I think, like I said in the beginning, we are entering a really interesting time now of people coming up with really great ideas, new innovative ways of producing food, which is very important because we're all working together with the FAO to reduce waste and to secure the food security for humankind.
Johan, thank you for this really interesting introduction into this topic of digitalization in the food industry and, as you mentioned, innovative solutions for the future. The aquaculture, the controlled breeding of marine animals, is one way to counteract overfishing of the oceans. The Dutch company Orange Aqua has set itself the goal of developing solutions to operate onshore aquaculture more efficiently, and it's also relying on automation. Let's have a closer look on how this works, and it's good to have the founder of Orange Aqua as our guest today. Jeroen Noordermeer is waiting for me in the hall. Let's visit him. Hi Jeroen, thanks for being with us today. Thanks for joining us.
You're welcome.
So could you give us at first a brief overview? What exactly is Orange Aqua's mission?
Yeah, actually in very short, it's to bring the aquaculture industry onto a higher level of technology.
Yeah.
And to implement a more digitalized way of controlling a system.
Yeah. So to do this, you rely on IO-Link. Why did you choose this technology exactly?
For us, it's really important that you can easily fix a system. So scalable sensors are usually a problem because you need skilled staff. And in a situation when you have an operator in a fish farm who needs to change out the sensor at night, for instance, you want to have an easy solution and you can just download the settings onto the new sensor, give it to the operator and say, just switch it out and everything is running well again.
Yeah. How important is it to have a quick running and quick to maintain solution regarding the challenges of an aquaculture system?
It's essential. You are actually having to maintain a life support system for the fish. So if the system is not running as it should be, especially if it's like key sensor which controls an important process, then you really need to be able to switch it out quickly and swiftly. So it's fairly important.
Okay, so let's talk about these important parts of an aquaculture system. Where do you use sensors and what do they ensure in this system?
We use sensors in the whole system to keep track of the water flow, let's say. We mainly use level sensors, flow sensors and temperature sensors, but the temperature sensors are usually incorporated in a sensor. And we use pressure sensors to check if pumps are working correctly.
Yeah. Okay. So just a little bit more details. What kind of flow sensors do you use? Is it only for ensure the whole system is running well?
No, we use flow sensors on the pumps to see how they're in what kind of operational mode they are and if they are working properly and if they supply enough water to the fish tanks. And we use flow cells to measure the inlet water to keep track of how much refreshment there's going on into the whole system. And we try to keep that somewhere between 0.5% and 5% water refreshment per day.
Yeah. So to raise a bit the sustainability factor of
That's why we build RAS systems. Yes.
Okay.
To reduce the energy usage per kilogram produced fish. And also reduce water.
Yeah, perfect. So we will later on talk about the perspectives of transforming aquaculture into aquaculture 4.0. But before, we will have a short look on how the company Urban Crop Solutions is pushing vertical indoor farming to the next level, also with the help of digitalization.
We are here located at the headquarters of Urban Crop Solutions in Waregem in Belgium. And Urban Crop Solutions is an end-to-end solution provider for the indoor vertical farming industry. So actually what we want to do is to bring the production of plants closer to the point of consumption or processing. I want to do this for food, for agriculture, for industry and for biotech. Right here, we are located in the research center of Urban Crop Solutions, where actually we want to investigate every single parameter of plant growth and optimize that to maximize the efficiency and return of investment for our clients. Now we have here 10 different research labs, each with their own purpose, with their own technological implementations when it comes down to research on different temperatures, lighting settings, irrigation methods, different vision technologies, and so on. At Urban Crop Solutions, we want to address the challenges our planet is faced with through growing population, growing urbanization, and lack of industrial or agricultural land. Now, and we do this by combining technology and biology to address these challenges and provide solutions for industry, retail, food, and biotech. The clientele that we serve today can actually be divided in multiple categories. One of them are actually commercial growers who want to transform food miles into food steps, grow very close to the point of consumption or processing, or even produce plants on the parking lot, which are then distributed, sold, prepared in the kitchen or in the restaurant next door.
Here at Plant, we grow herbs and vegetables on the edge of the port of Antwerp and the city of Antwerp. We try to do that in the most sustainable fashion as possible, and for that we use a controlled environment aquaculture system, or better known as a vertical farm. Now we have restaurants as clients and consumers as clients. For our consumers, we deliver directly by bike in our packages. Our second group of clients are restaurants. We have very sustainability-focused restaurants, but we also have high-end restaurants, which really need top-level produce. We have a clean, sustainable, but very, very tasty product.
For the sensors, we really choose EFM, and we have selected 5 different sensors, and they are all working like they should be, without any problems. We never had a failure of one, but even if it would happen, then we really can have fast spare parts as well from Germany or somewhere else in the world. So that is the reason why we selected EFM to work with for all our sensors in the containers. Our containers are also worldwide presented, so we really need a fast service, what we have with EFM. That's very helpful for us and very important as well. Together with a good relation, we can adapt very fast and find the best solution for our customers, wherever they are, to help them when they need it.
So we are back in the studio, and now I'm pleased to welcome Martin van der Kroijs from Urban Crop Solutions. Welcome, Martin.
Hello, pleasure to be here.
Thank you. And I also would like to welcome Dr. Werner Kloers from the Leibniz Institute of Freshwater Ecology and Inland Fisheries. Welcome.
Welcome.
Thanks for being here today. And also with us back in the studio is Jeroen Noordermeer. Thank you again for being here.
Thank you.
So Martin, Urban Crop Solutions is in the topic of vertical indoor farming since 9 years now, and you're describing it as the next agriculture revolutions. How far is this revolution progressed in these 9 years, and what role does digitalization play in this part?
Well, first of all, we have to understand that we're still a very young industry, right? So actually, the last decade for us has actually been a period of discovery and valorization. So at first we've actually established how can we grow plants in a closed environment as good as possible. So trying to give them the right temperature, humidity, light, right at that moment they need it, so we get a qualitative and homogeneous product out of there. So that required a lot of research and plant science. But actually at the same time, we had to combine this with, well, technological engineering. And it's actually those crossroads where this industry is located. And well, so at first we had to establish all the right parameters to establish a good solution that can create this environment for these plants. right now we're seeing that we can use technology to make way faster advancements in our research. We have to understand, like, creating a growing recipe for a plant, or multiple trials, and it can take years. But right now, by collecting the right data and getting all the right sensor information in, we can actually even evolve to creating digital twins. And what I see is that by bringing all these technologies together, the speed where we can get to a more sustainable and better tomorrow will be way faster.
Okay. When we think about indoor farming nowadays, I would think about maybe tomatoes, lettuce, and as we saw in the video, spices. At the end of this revolution, will there be crops growing in indoor farming solutions?
Well, that depends how you look at it. And maybe you should take a step back and look at history. So first of all, we had people being nomads, right, traveling around. Then they suddenly discovered the art of cultivating plants and they were able to settle down. And then many centuries later, they discovered greenhouses and they were able to grow, for example, warm climate plants in cold climate environments. So actually creating a wider differentiation of food. Right now, more recently, we've seen that with indoor farms, we can create any climate anywhere on the planet. And well, if we're then seeing what we're having globally, it does not mean that we have one system that needs to, well, do everything or define everything. In the end, the key objective is trying to work on a more sustainable system, entire value chain. And this is, of course, environmental sustainability. This is, of course, nutritional sustainability, but also financial sustainability. And whether that is with just an indoor farm, whereas with just a greenhouse or an open field cultivation, well, there is no one solution fits all. It could very well be that we grow young plants actually here, and then the bigger plants in an indoor farm, and the younger and the mature plants actually in open fields.
Okay, so this is maybe also the second part of urban crop solutions. You're not also only in driving these indoor farming solutions, but you are also, as you already mentioned, in plant research. You have got your own laboratories for that. What is the objective here exactly?
Well, initially, research was a necessity to develop the right system, right? To understand what we need to have, which measurements, which controls need to be in place, so our clients can have a guaranteed output and a guaranteed functionality. But right now, the longer we're in this business, the more we're learning what we don't know yet. And our research center actually functions for, well, three main objectives. On the one hand, we're doing, well, fundamental research for ourselves, thinking of what are the applications of the future. This can be, for example, plants for industrial applications or for plant molecular farming. On the other hand, we're doing joint research with partners. One example is a project where we're trying to replace, well, unsustainable substrates with natural fibers which are completely compostable, actually to optimize the entire ecosystem that we have. And then the third activity is contract research for external companies, such as, for example, plant breeders who want to, well, shorten the speed of developing new plant varieties or optimizing them for indoor farming cultivation.
Okay, but it's also then helpful to get plants that maybe cope with the upcoming climate changes. Is it also a topic for you?
Not just that, because we have this controlled environment, we are actually disconnected from the outdoor environment. So we're free from pests and diseases, and we can create any climate we want anywhere on the world. But actually, the key objective they're trying to identify in all these research activities is trying to do more with less, get more output, more quality, with less natural resources.
Okay, perfect. Thank you. Jeroen, we've seen already a bit of aquaculture earlier in this episode. Orange Aqua had set itself the goal of establishing aquaculture 4.0. I read that on the website. So are you also aiming at some kind of revolution of aquaculture?
I studied agricultural engineering and after that aquaculture. And I always make a comparison of the technology from agricultural industries with aquaculture industries. And in that sense, aquaculture is lacking behind in my sense. It's like, it still needs a lot to learn. It's a quite fast developing industry. I would like to take that knowledge we have from agriculture into aquaculture, because they are quite overlapping industries. It's about process control. We learned at my studies that a cow is a box, and something goes in and something needs to come out, and we are here to turn those knobs on the cow. So we can control the environment. That's basically what we do, and that also happens in aquaculture, of course. And since my company is actually a little bit a bridge function for agriculture into aquaculture, that's how I planned it, or at least why I made that company myself and not start working for another company, and try to implement the sensor technology, artificial intelligence, the controls which you have into the aquaculture industry.
Would you say that the aquaculture industry is already ready, or at least open to use automation and digitalization solutions?
In certain cases, yes, but I think it's dependent on the country. It's mainly it's a financial questionnaire. If it's feasible, yes or no, because if labor is cheap, automation usually is not valid or not profitable. But in high wage countries, then it could be definitely worth something. And on the other hand, you have the sustainability aspect of a system. So if you can predict waste values, for instance, or waste production of a system, and you can anticipate on it, that increases the efficiency and also uses less water. Because I think you were talking about, Maarten, about the sustainability aspect of a system which is closed, but I think water is even more important. And controlling an environment is easy, but water you always need. And in the world, there's a lot more salinization now, so a lot less fresh water available, and I think that will be the biggest sustainability questionnaire in the future. And also to make, for instance, plant more saltwater resistance instead of being able to adapt in a certain environment, because that environment you can create, for instance.
So you already mentioned you're not only using sensor technology, but also artificial intelligence. Yes. How far is aquaculture, or how far is Orange Aqua on the way to really the high-end aquaculture? What kind of potential do you see? Where can you still improve aquaculture?
I think the aquaculture itself is quite developed, but it's like a 2.0 level. Of course, you have companies in the Netherlands and in America and other developed countries which are quite high-end, but there's not an industry standard. It's mainly individual systems which do not really talk with each other, or when they do talk with each other, it's like a very custom-made system. And what we try to do is to make a modular system, sensor-based, which can talk with all the aquaculture components, so that you can control everything in one system instead of having 7 different systems talking with each other, because that's usually where the pain of controlling something is, to let those systems talk with each other. So you have Modbus, Profinet, you maybe have analog sensors which you need to scale. You have your PLC, maybe different brands from a subsystem. Trying to make those work together is really hard. And we really try to make one system out of it. In collaboration with IFM.
Okay, perfect. So, Dr. Werner Kloers, as mentioned, you are from the Leibniz Institute of Freshwater Ecology and Fish and Industry, and you had the Aquaponics and Ecophysiology Research Group. I hope that was right. So, what is the focus of your research?
Yeah, so the main focus of our research is sustainable aquaculture, and we are looking for sustainability towards land-based aquaculture, so meaning closed recirculation systems, not in contact with with the environment, to save the environment. And like that, one of the solutions to make it really sustainable is to combine land-based recirculation aquaculture system with horticulture. So that's aquaponics basically. So we are combining aquaculture with horticulture. and to make the benefit, because otherwise you have still some water nutrient reach from the fish part. And so you will have at least a double use or even a morefold use of water, especially, but also of the nutrients to bring them to the plants. And that's one of the main ideas what we are working on. Right now, we are also going beyond aquaponics. So in multi-trophic systems, so even integrating then insects, for instance, for some leftovers to make also again some valuable parts out of it. But so main part in the last 15 years has been aquaponics.
Can you name the benefits in some numbers? So can you tell how much of whatever we can save when combining aquaculture and agriculture?
This is a good question, because this is very much depending on the technology you are applying. So we had already the discussion about level 2.0 or 4.0 for the systems. So if you have a high advanced system, so we would combine it with a low energy greenhouse. So this concept has been developed by one of our colleagues from Humboldt University, Uwe Schmidt. And this is meaning you have then regaining of the evapotranspirated water again. So you can refed the water from the plants into the aquaculture system. So when you might have nearly a closed water cycle. So like that, you could save 90% of the water. In Middle Europe, you can even save this water by catching it from the rain. So that would be that you have really very sustainable system, that it's just self-sustained concerning the water cycle. The other part is the nutrients from the fish part. So if you have a recirculation system, you will create high levels of nitrate, for instance, and you could supplement with this nitrate levels completely the plant part. So some other parts like potassium, calcium, might be still missing, but you can somehow, depending on what you want to rear, how do you rearing the fish, you can supplement at least more than 50% of the nutrients as for fertilizing the plants. Like that, water is in such a system, in a sophisticated system, water could nearly be independent if you are collecting the rain, but it's a high-tech system then. And you can make, if you're not going for regain the water, not closing the water cycle, then at least it's a double use of water. And this is also helpful and better than just going for separated systems.
So this is maybe a win-win situation for aquaculture and agriculture. How big is the interest in your research regarding to the industries? Is it establishing already, or what are the main tasks you have to fulfill? Maybe that it's a beneficial and successful solution.
I think it's a big interest from both sides, from aquaculture, from horticulture. The problem is that aquaponics has some also history. And the history since 80 years or more is kind of systems. You have a one recirculation system. You have the fish part, the fish water with nutrients coming to the plants, and it's coming back to fish. But fish needs a pH, neutral pH of about 7. The plants would like to have 6 or lower, something like that. So you will not make in such a system, you cannot make the fish happy and the plants happy at the same time. And that means you need much more water, you need much more, so you will not get the same yield. You can only make herbs and salads, no tomatoes, which need request a lot of nutrients, for instance, or pepper. So it doesn't work for all. So for the, let's say, most commercial greenhouse products like tomatoes and cucumbers and so on. And in 2008, we implemented a new technology having a double recirculation system. One recirculation system for the aquaculture, like Jerome was talking about, one closed recirculation, and the wastewater, which is a fertilizer or at least a partial fertilizer, is then transferred in a reservoir for the plants. And then we are changing or adapting the pH to have an optimum condition. We are also supplementing what is missing for the specific plant we want to rear. And I think that's a solution that you can have the same yield as in separated system. Otherwise, it wouldn't work.
Yeah.
And that started in 2008, 2009. We had the first results that it works. And still, some people are still going for the one recirculation system. We are propagating the double recirculation system. It's more or less on the way, but there has to be, I would say, one startup to show it in a bigger facility that it works. And right now in research, it works fine. And we are working on that. It's convincing, but as long as no one has proven it, that it's in an industrial scale, it works, it will not get a broad, let's say, audience.
Okay. So you're focusing on onshore aquaculture, and then we have, of course, onshore agriculture, and we have vertical indoor farming, which is also independent in the placement. So would these two solutions together combined, would this be the perfect situation for the double circulation aquaponic?
Exactly.
Yeah.
That's just to connect both of them. And then if you are going for let's say for regaining the water, you need usually to have a controlled environment. Also in plant horticulture, you want to have a cooling system. You will anyway you will get to regain the water, and then you can go it again through the fish part, and then you will save a lot of nutrients. So that's nothing else than combining such parts.
You know, Martin, how does it sound for you? Have you already been into the topic of aquaponic, and is that something that you are having already in mind? Maybe.
Well, from the end of Urban Crop Solutions, our expertise is creating these environments and solutions to grow plants. But we do have one client actually in Aachen in Germany, who are actually producing saltwater fish in an aquaponic system or an aquaculture system. And they're combining it then with our technology where they're growing saltwater plants, it's Salicornia, which are very rich in minerals and which have a very low availability actually in nature or overall. And they're doing this successfully already for over a year today. And I can only say the approach, and like described, of trying to use waste streams or residual streams of one technology or industry to optimize another one. In their case, is indeed salt water from the fish and waste streams from these fish, combined with the carbon dioxide, because apparently there's also a lot of carbon dioxide production there. And they're inserting this then actually in a separate system with separate controls to their indoor farm. And I think this ecosystem thinking, this will be actually the methodology that we need to approach to work for a better tomorrow.
Yeah. Okay. Thank you. How about you?
Well, I think there is actually already a proven concept of this, that is Omega Bars, and that's in Belgium, which is working with a decoupled aquaculture system. I think that's what you mean with the two recirculation parts. We didn't build it, but it still exists, and I did not hear that it collapsed. And that's based on a big tomato farm, which also uses the CO2 of the fish, I think, or at least the heat part, and of course the nutrients. But for Orange Aqua's perspective, it's not our main goal to couple or combine those two industry. We really focus on the technology part, and of course, if a client wants that, we can build that system. But for us, biology is, we hire experts for that, let's say. That's not our main business. So we try to stay away from that a little bit. Really focus on the technical part.
Okay, so it's more or less research and industries, and you can deliver the solutions from the aquaculture part. Yeah.
Yes.
All right. So I would like to thank you all three once again for being here today. It was really interesting. I hope this aquaponic solution will establish in the future then. Thank you, Martin van der Kroes. Thank you, Dr. Werner Kloos. Thank you, Jeroen Lodermeer. And thank you for watching us today. It was a pleasure. I hope it was interesting for you too. I hope you will join us the next time again. Until then, take care of you, stay healthy, and bye.